and you all are familiar with traffic signs. Traditional signs, stop signs, yield signs. We don't typically use yield signs at intersections in most of the United States. There's not a good reason why, but practice has evolved to requiring cars to stop at intersections rather than yield. But why might we seek alternatives to traditional signals and signs? Okay, talk with your neighbor for 30 seconds and come up with a list of reasons why we want to use things other than traditional signals and signs. Start with number 18.
Signals and traditional signs make traffic stop.
Okay, so there's a delay cost in terms of time. All right. What else? Okay. Additional wear and tear on the vehicles. So when you're forcing the vehicles to come to a stop, you're adding delay, you're also adding wear and tear on the vehicles.
We save money from implementing a street or a traffic signal.
Traffic signals are expensive. Signs are really cheap. Other things may or may not be cheap depending on what you do.
Like roundabouts, drivers kind of involved. They are not on the line. They are kind of involved, so they can't pay attention. It leads accidents.
Drivers have to turn their brains on more.
Right.
Okay, and so that increases safety because drivers are paying more attention. Carly. Okay, so cost.
Increases emissions.
Okay, making cars stop and accelerate increases emissions because you're burning a lot more fuel because you've wasted all of that energy, the momentum that you had by braking.
It gives people more the chance to think about the condition of the road all the time. They have to stop and analyze why they have to yield.
Okay, so traffic signals give people time to contemplate. So is that a good thing?
Yeah.
Yeah, okay, so traffic signals are good because they give people time to think. Okay, that's a new perspective. Not wrong, it's just not usually thought about as a way of doing it. But the argument has been made that time on a train, for instance, is less wasted than time in a car because you have time to do other things. I've never heard that argued about time at a traffic signal, but the question is, what is the alternative? So it's time sitting at the traffic signal versus time sitting at your destination. So I don't know which you'd prefer. Which is safer? Traffic signal, stop sign, a yield sign, a roundabout? What does it depend on? So it depends on the traffic going through the intersection. Okay, so one of the issues with traffic signals and four-way intersections is, if you remember from the beginning of the course, the first day of the course, you saw the video of the cars colliding at a right angle, and that was a pretty bad collision. With modern roundabouts, if there's going to be a collision, it's going to be at a much less sharp angle. Okay, and as a result, it's not going to be as dangerous for the vehicles involved. Also, they'll tend to be going at a slower speed because the vehicles in the roundabout aren't going too fast, and the vehicles that are merging into the roundabout also aren't going too fast because there's a physical object in the middle of the intersection. Whereas if you have a green light and you see it, you'll at least maintain your speed, and you might accelerate for fear that you're going to lose the green light if you don't accelerate. So there's safety issues. So we're going to talk about roundabouts. Most examples I'll give you today are the U.S. It works the same, and it works equivalently in the U.K., except people drive on the wrong side of the road. So at the end of the class, I'm going to show you a roundabout in the UK where they're just driving on the wrong side of the road, but it's more complicated than that in the example that I'll give. But in the U.S. example, vehicles are approaching. This is a 2-lane roundabout. And so there's 2 approach lanes from every leg. And you can see there is an island in the middle. And there's signs. My particular view, there's too many signs that are shown here. I don't know why we need to mark every pedestrian crossing with both a sign and a pedestrian crossing markings, given that the driver should be paying attention to the markings. And if you put signs in some places, they'll expect signs everywhere. And if they expect signs everywhere and they're not everywhere, then they're going to ignore the places where there's not signs, and that'll create hazards elsewhere. But traffic engineers, I think, are nervous and are only thinking about the local issue, and they want to let drivers know that there is a pedestrian crossing. Note that the pedestrian crossing is not here, but it is set back farther, which means farther down the approach, which means pedestrians have a longer walk at a roundabout. So, potential downside of roundabouts. How might we deal with that if we had a high pedestrian volume? Raising.
Like the pedestrian paths, I actually saw like a concept or an actual thing of kids' sleep where they actually have a roundabout intersection that have a large bike path that's suspended above the intersection.
Suspending it. Okay. So that's an idea. It depends on the grade. Okay. What you often see in England is a tunnel from each of the sidewalks into the center. Okay, which means that if you're going this way, you're going a little bit longer because you're going into the island area and then coming out. But if you're making a right turn as a pedestrian, it's shorter because you get to cut the diagonal. Okay, so putting a pedestrian path to here under the roadway is a possibility and is an option. And it's done in a lot of places in the UK. It's not done here very frequently. The downside is, do pedestrians like walking in tunnels? Not generally. Okay, why don't pedestrians like walking in tunnels? Safety? No sunlight. They don't like walking in tunnels because of the rain?
Well, I guess you could put drainage in.
You're civil engineers. Okay, let's imagine you've engineered it properly. You put drainage in. Okay. So it doesn't flood, and it's protected from the rain because it's in a tunnel, and you've put an appropriate, unlike this building, we have appropriate water techniques to prevent water from permeating the structure itself. Okay. What else? Safety has no sunlight. Why is it unsafe? Or why is it perceived as unsafe? Why wouldn't you know what's under there?
If you're up in an open ground, you get to see like way far ahead of you. If you're in a tunnel, you're kind of far ahead.
Okay. So if the tunnel looks sort of like that, okay, you can do something with the angles in here and make it less. Okay. And if you're here, you can see, you can't see through walls, so I'll make it a wall there. You can see to here, you can see to the other end there, you can see to there maybe you can see it over there, but there's this large area where you can't see what's behind a corner. And in a tunnel, people get nervous. Okay, so what are solutions to this? Okay, so you could put mirrors here, and that would increase the distance that people could see. Okay. What else could you do to make pedestrian tunnels less scary? Okay, so this is the middle of an island. So this could be either open to the air or have a skylight if you don't want to make it open because of drainage issues or whatever. You could have a skylight in the center of it. I've seen them being open. What else? Glass blocks where?
Probably right on the sidewalk.
Okay. So, how do glass blocks help you? So you should be able to see through here. Okay. So you just make it the whole thing one giant circle, and then you have the roads going over top the circle. That requires more cut and fill, so you're probably removing a lot more dirt than you'd want to if you were doing that. But it's certainly a possibility to just make this whole thing a two-level structure, and the ground floor just be an open area. How do we normally protect people in the United States? Huh? Guns. Okay. Well, even if we don't give everybody guns, who do we give guns to? Guards, security officers, police. Okay? And even if you don't want police everywhere, you can put cameras. Okay? And then cameras all around. And so that's done in a lot of places. When I was a student, I was at Georgia Tech. There was a tunnel under I-75, I-85, the big highway through downtown Atlanta. And they put cameras in there, and they had gates on either end. And so if they thought that there was somebody doing something wrong inside the tunnel, they'd close the gates remotely and lock you in there. And if you put your hands on the camera, they'd close the gates and lock you in there. And so you don't necessarily want to be locked in there with a bad guy, but if somebody's already done something like that, and you can somehow isolate them, and you don't have to just have one set of gates, you can have gates in a couple of different places, you can probably ensure safety inside of the tunnels with remote monitoring. And we do remote monitoring of lots of systems. We do remote monitoring of our highways all the time, so that if there's a collision on a highway, somebody knows about it almost instantly because of the monitoring. So there are things that can be done, but it does, if you don't do tunnels, you are increasing the travel costs for pedestrians, and so that's a thing to keep in mind. Geometric elements, so the pedestrian crossing, and obviously it's an accessible pedestrian crossing, everything is compliant with the Americans with Disabilities Act, you have ramps, and the ramps are appropriate grades, and so on. There is a median island here called a splitter island, which gives pedestrians a refuge so that they only have to look one way when they're crossing, and then they can get to a refuge island, and then they can look the other way and cross the other side. You could put pedestrian actuated signals. I've seen that done in places. That's got downsides, because one of the advantages of roundabouts is you don't have to put signals in, and if you start putting signals in, then you make it a little bit more complicated. Depends on what your pedestrian flows are. A yield line, car here has to look this way to see whether they can yield to enter, but they're only looking in one direction at a time because they only have one conflict that they have to cross. And then this is a single lane roundabout. There is the central island. Okay, you might put bicycle lanes in on the side. In this particular example, they call them bicycle treatments, and it's sort of odd because then the bicycles have to converge into traffic, so I'm not exactly sure what the advantage of that design is, but and then this is the circulatory roadway. Okay, the apron is a concrete strip on the edge of this, on the inside edge. Why would we put an apron there? A concrete apron on the inside of this. Right, so this is a fairly sharp angle, okay, depending on how big the roundabout circle is, and if it's not big enough, then semis, big trucks are going to have a hard time going around like this, and so they would prefer to cut the corner a little bit less sharply and not have as much radius of curvature. The advantage, the safety advantage, okay, drivers are paying more attention. That's one thing to keep in mind. But there's a lot fewer conflict points, in addition to the conflict points being at a low angle. And so you definitely have fewer conflicts, and they're lower speed, lower angle, and thus lower energy, okay, and therefore less damaging. And so this is a major advantage to roundabouts over four-way stops or yields or signalized intersections. Okay. There's also fewer pedestrian conflict points. Okay. Pedestrian has fewer things to think about. And so it should be safer for pedestrians, although it's a little bit less convenient. Now, we don't use them a lot in the United States. There's some historical reasons. Okay. If you've ever been to Washington, D.C., you know there's a lot of traffic circles in Washington, D.C. Those traffic circles are not modern roundabouts. Those were designed back in the 1700s before the automobile. Reportedly, the story goes, L'Enfant, the architect planner of Washington, D.C., put in rotaries put in these traffic circles, these big circles, and both because of a design sensibility. This was popular in the era. But if you have eight roads coming together at a single point and an island in the middle, you can put a cannon in the middle and point it in any of 8 directions and shoot at the oncoming mob. Okay, so this was the period of the French Revolution, and people were concerned about hordes of people and overthrowing governments and things like that. So the intention was certainly not traffic control, and if you look at how they are today, they're far bigger than that. The circles are typically far bigger than modern roundabouts would be. They're often traffic signal controlled, have a lot of other issues with them. Rotaries were implemented in a number of places. The difference between rotaries and modern roundabouts, the primary difference is who has to yield. So it used to be that the traffic in the circle yielded to the merging traffic. And now the traffic outside the circle yields to the traffic inside the circle. Why is that better? It keeps the traffic in the inside flowing. You don't have the potential for gridlock in the middle if they have the right of way. Okay. Why didn't people think of this in the 1900s or the 1940s? Because there's too much lead in the water. Okay. I'm only half joking. People were burning leaded gasoline well until the early 1980s, and lead paint and all sorts of other things. And you must have heard the story about why the Roman Empire fell, because the Roman population got stupid because they were using lead pipes. There is evidence that IQs are rising over time, and there's a number of possible reasons for that, but we don't burn leaded gasoline anymore is a really strong possible explanatory factor. So it should have been obvious really early on that that was a bad rule and would have easily changed, but it turned out not to happen. So people moved into traffic signals. There's a whole industry around traffic signals. A whole bunch of engineers are trained to do traffic signals, and so it sort of self-sustains that if everyone knows how to do traffic signals, that's what they do. The UK figured out in 1963, so only 50 years ago, to reverse the traffic priority. And they started doing this in a number of their newer developments. Now, much of England, of course, was already built up, and it's hard to retrofit places. But if you're building a new development, it's much easier to put in a roundabout at that time because you don't have the built environment around it. And this spreads throughout Europe and Australia, and they're widely seen in both of those places. But it takes into the 1990s before they even start getting deployed in the U.S. Stevenage is a planned community with essentially no traffic signals. So it's a town of 50,000 people, so maybe a little bit, roughly on the order of Woodbury or something like that. And instead of having traffic lights at every intersection, they planned and they put in roundabouts. And at the major intersections, they have these kinds of crossings for pedestrians. And you can see them in Google Maps in various places, okay, where in a similarly sized U.S. subdivision, they would have put in traffic lights. Now, another downside of roundabouts, or potential downside of roundabouts, they might use up a little bit more land than a four-way intersection because you have this center island which isn't doing anything functional. And so that's a potential concern. But if you look at suburban developments, it's not like they're packing everything into every last inch of land. If you were to say in the city of London or in the downtown Minneapolis, roundabouts would use up too much land, that might be a reasonable argument. But to say in a place like Woodbury or Roseville or Maple Grove or Apple Valley that would use up too much land is not a really salient argument, because they're wasting land on all sorts of things in those places because land isn't scarce there. Or in Stevenage, land wasn't scarce. So as of 2009, the number of roundabouts in the U.S. Can be counted. Minnesota has, according to this, at least one. And of course, there are more than one, and I'll show you a video of one. But states with a lot of them are in yellow. And, there's no national roundabout agency that collects statistics, so you sort of have to figure this out ad hoc. But it's increasing, because if you went to 1990, the number would be approximately zero, not quite zero, because there'd be some rotaries that might have converted to roundabout operation, but these are ones that are typically operated using modern rules and modern design standards. So in the Twin Cities area, there are some that have been built out in Ridgefield and Washington County. The new 169, 494 interchange has this at some of the ramps. So instead of having a traditional cloverleaf, which is bad for a variety of reasons, mostly because you have all of the weaving action, the roundabout helps reduce the number of conflicts and lets people sort themselves on the roundabout off of the highways rather than on the highways. And so it's being used as an interchange design there. A new Mythbusters episode came out with a segment on roundabouts. This link is on the Moodle page now. I'd encourage you to see it. It compares roundabouts with four-way stops, and they get a bunch of people to drive in both of them and move cars around. It's sort of cool. So I'd encourage you to watch this. And then I've got a short example from Richfield. Oops. Okay. So this is in Richfield, near the Target off of Highway 77, Cedar Avenue. It's really interesting. You see three buses from three different approaches using the roundabout at almost the same time. And you can see they've offset the pedestrians a little bit here. This is a two-lane roundabout approach. Okay. I guess the camera is wobbling. It's on a giant stick. So typically, if in peak times, everyone's waiting a little bit, but no one's waiting a long period of time. So unlike a traffic signal with maybe a 60-second cycle length and 30 seconds for each phase, where the average driver would be waiting 15 seconds, nobody's waiting 15 seconds here. Now, some of the drivers are a little bit nervous about merging in for obvious reasons. So that makes people feel uncomfortable. This doesn't mean it's unsafe, because people feeling uncomfortable means that people will be paying attention to their environment. They don't like to have to pay attention to their environment, but it's safer for them if they do. And of course, drivers are going to be really nervous when there's a police car in the roundabout. Okay, now you got a pedestrian crossing. So we got a pedestrian crossing. What happens? Crosses the first one, no problem. Sees the car stop, begins to cross the second one. Oh, is the second car going to stop? I better scurry along. So the pedestrian environment's not optimal. Okay, so from the pedestrian's point of view, the pedestrian shouldn't have to scurry to get across. That's just a short clip just to show you how these things work. You go to YouTube. This is the Mythbusters episode, by the way. You can sort of see the Mythbusters guy. I forget what his name is, but somebody in here knows. That would be Adam Savage. Yes, that sounds right. Okay, so I had a student a few years ago, Ruben Collins, who is now the pedestrian bicycle planner for St. Paul. And he did his master's paper on evaluating a roundabout at a five-way intersection using microsimulation. And so, we know these benefits. It reduces the number of crash. It reduces crash severity. It reduces delay. It increases safety. Okay. It reduces the cost of signal infrastructure. But when does this happen? Okay. Roundabouts are new. We don't have as many tools for analyzing roundabouts as traffic signals. Of course, we have tools, but they're not as sophisticated. Okay. And they're not good at handling complicated situations. So, the case that he was looking at was this intersection right here, which you might be familiar with, East River Road, Franklin Avenue, and 27th Avenue Southeast, okay, which is a five-way intersection. And he did this in 2008 or so. They were looking at redesigning the intersection a few years ago. So he did this before the county did their study. Because the Central Corridor is coming in, and the hypothesis would be that if Washington Avenue were closed to traffic, which it has been, that more traffic would use East River Road. Certainly some more traffic has. And that would already put this intersection, which was performing poorly, into to be performing more poorly. And so the question was, can you put a roundabout here? Okay, so the space clearly indicates that there's enough room to do so. Okay, now you're not going to put anything on this side because this is a steep cliff down to the river. Okay, this is Franklin Avenue Bridge. This is East River Road. This is Franklin Avenue Southeast. There's an island here. There is a auto repair place there, Southeast Auto Repair. There is a parking lot for that apartment building right there, which used to be the Good Samaritans. And I walk this way to school every day, so I always found it amusing, one, when the Good Samaritans didn't shovel their sidewalk because they're supposed to be Good Samaritans, and second, that they had really large fines for parking there and not going to the Good Samaritan building because you'd think they were Good Samaritans and they'd be helping people out. But not to pick on the Samaritans, it's just sort of amusing. So you can look at this and say, well, there's certainly plenty of room to do something in this area. There's a pedestrian refuge island here that you could look at. And this is what it looked like before. So this is sort of the before view. If you've been there recently, the lane configuration is now a little bit different. They've put bike lanes on Franklin Avenue over here, so they've narrowed this down to one lane in each direction plus a bike lane. And they've narrowed this to 2 lanes here since then, with one through and left turn lane and one right turn lane. Because there's a 5-way intersection, so there's sort of 2 right turns depending on how you think about it, or 2 through movements depending on how you think about it. Okay. So 5-way intersections are inherently going to have more delay than 4-way intersections because you have to have at least 1 extra phase, if not up to 2 or 3 extra phases, depending on how you do it. There was high delay there, except for the peak period, the volumes were fairly low. Okay, so this is one of the issues with traffic signals is traffic signals will tend to work well if you're near saturation or if you're oversaturated because you have to allocate the time and it'll bunch the traffic up so you have less lost time than a stop control. But in the low volume areas, you still have a minimum cycle length, and so you're making everybody stop even when nobody would have to stop because the traffic volumes are low. Okay, there's space available. The angles are odd. The odd angles also make it harder to do a traffic signal, and you have to adjust them a little bit for a roundabout, but make it easier to do a roundabout in high pedestrian flows. So he did some counts. Okay, the blue lines are the counts that he did. The red lines are the counts that the Minneapolis Public Works had done. I can't tell you why his counts are lower than theirs. They were done on different days, but it's sort of a general observation that any count that you do will be lower than any count that the city of Minneapolis does. You can think of the reasons why that might be the case. Okay, the traffic is directional. So if you're looking at the traffic from different directions, the worst times of day are the morning peak and the afternoon peak. So it's just like the diurnal curves we saw earlier in the course, except this is just looking at the different approaches. But so Franklin Avenue eastbound is the yellow, or I guess light green, depending on lime green, depending on how you think about it. Westbound is the light blue. Okay, and for whatever reason, there's more traffic both on Franklin Avenue eastbound than there is on Franklin Avenue westbound approaching the intersection. It's asymmetric. Okay, so all the traffic that enters the intersection has to leave, but it doesn't all stay on Franklin. More of it that's on Franklin coming across eastbound is coming across the bridge is going to turn onto East River Road to go to campus, for instance. So there's a heavy flow from campus to Franklin Avenue East. So it's a right turn movement in the afternoon, a left turn movement in the morning. But it's peaked higher on that movement all day long. So that's just sort of an oddity of this. Whereas River Parkway northbound peaks in the morning and River Parkway southbound peaks in the evening. Okay, so you can look at the scale here. You're talking about up to 200 vehicles per 15 minutes or up to 800 vehicles an hour from some of these approaches, okay, which if they had 1,800 of vehicle of green time, 1,800 vehicles per hour of green time, and they're at 800 vehicles per hour, you can think about how much green time do they need to ensure that they're under capacity. So they would need at least 8/18ths or 4/9 of the cycle in order to be under capacity. So that's going to affect the timing of the approaches. You can look at the trucks. Now the scale here is different. Pedestrians, trucks and buses, not too many. Pedestrian counts are pretty high, and bicycle counts. And this was done like 5 years ago. I'm fairly confident the bicycle counts have actually gone up significantly here because they put in some bicycle lanes. So we've got the existing conditions as of 2008. 3 lanes approaching on Franklin Avenue Bridge, 2 lanes on going northbound on River Road, 3 lanes southbound on River Road at the intersection at the time, 2 lanes on Franklin Avenue, 3 lanes on 27th Avenue southbound. Okay. And so the intersection flares out. The intersection flares out in order to give more vehicles the opportunity to use the green time, because vehicles that are sharing lanes can do that. So this is the base condition, and this is the kinds of delays that you're getting. And on East River Parkway southbound, vehicles were sometimes waiting at sort of the peak time, 1700, 5 p.m., would be waiting as long as 200 seconds on average. Okay, so more than 3 minutes of delay per vehicle, and you can multiply that by the number of vehicles to get the total system delay, and so that's a significant amount of delay. So he proposed looking at protected movements, so changing the signal timing. This is roughly what happened. They also changed the lane configuration as well. And if you do that, okay, you reduce the delay somewhat. Okay, it's sort of hard to see, but the delay is a little bit lower here than it was in this example. Okay. Then he looked at a couple of roundabout options. First was a 1-lane roundabout, okay, and with 2 scenarios within that, one where the cars yield to pedestrians and one where the pedestrians yield to cars. Okay, so what is the rule? Now, it turns out that in practice, the rule is going to be somewhere in between. The actual practice is going to be somewhere in between these, although a pedestrian should be able to step into the crosswalk and the cars have to stop. A lot of pedestrians are too nervous to step into the crosswalk and make the cars stop. So, and this is a cultural thing. So if you go into California, you'll see pedestrians not paying attention to the road with the expectation that cars will stop, and I'd say Northern California, and the cars will stop, okay, and pedestrians don't get hit because the drivers know that that's the expectation, so they have to be mindful of pedestrians. Here, drivers think that pedestrians are nervous and therefore will be aggressive. So until pedestrians get aggressive, then drivers will be more cautious, but it's a cultural thing. So what happens to delay? You put in a roundabout. We still have problems on East River Parkway southbound, okay, and that's actually gets a little bit worse in example 3A, but everything else goes to almost no delay, okay, except a little bit in the morning peak. 3B is not as bad, okay. And you say, well, there's some unbalanced demand, okay. Maybe we could put in pedestrian signals. Okay, that reduces delay significantly because then the signals control when the pedestrians enter the roadway. And so the scale is significantly lower here. Okay. But we could put in a 2-lane roundabout. Okay, you have enough room to do that. You need to have additional approaches. Again, 5A, scenario 5A assumes the vehicles stop for pedestrians. 5B assumes the pedestrians stop for vehicles. And now look at the delay. Now this is not a scale from 0 to 400. This is a scale from 0 to 12 seconds. Okay, so the delay is almost 0 now compared to where it was before. Okay. And similarly with 5B, it's still almost 0. And then you do some flared entries. You have a slip lane here from River Road southbound to Franklin Avenue westbound. So you take some traffic out of the roundabout, okay, at the cost of an additional pedestrian crossing. Okay, so keep that in mind. But the advantage of that is it moves the vehicles through potentially a little bit more quickly. But it also has pedestrian signals, and that doesn't do as well. Okay. And so this is comparing them all on the same graph. And so scenarios 5 and 6 are down here. So what are the implications? One, we could use roundabouts to reduce delay. You need to be careful about where you do them, of course. So sort of the general caveats about engineers. There's a question of trading off delay. So you might improve it for some movements and worsen it for others, potentially, depending on how you design it. Okay. So we've talked about the advantages and disadvantages, so keep this in mind. We don't have a roundabout there. So Hennepin County in 2010 studied this intersection. Okay, they considered roundabouts. Roundabouts came out favorably on all the criteria that we just looked at. I mean, Rubin's analysis was fairly good. Yet they put in an improved traffic signal, okay, which did reduce delay compared to the previous signal timings in the previous intersection configuration, but not nearly as much as a roundabout would. Okay, so the engineer for Hennepin County said, oh, it's the community. The community didn't want this. Okay, so the community being Prospect Park neighborhood that is up the hill. Why would the community be opposed?
They use it frequently, and installing a roundabout would make them have to drive elsewhere to get across the bridge for
You mean for the construction time? Yeah. Okay, so it's the construction issue, but they rebuilt the intersection, had a lot of construction anyway. I've got some really interesting videos of what it was like during the construction. It was operating as a 5-way stop during the construction period. And so the current signal configuration, I've estimated, has a capacity of about 1,900 vehicles per hour. During the construction, when it was operating as a 5-way stop, you can imagine how drivers behave at a 5-way stop. It's really quite fascinating because nobody knows where to go. The capacity went down. It was about 1,600 vehicles per hour. It was still a pretty good throughput. Everybody was nervous. My own view is that they should have just left it as a 5-way stop, dirt-covered road when they were doing the construction. That was sort of the best solution, even though it was a little bit less delay. during peak, a little bit more delay during peak hours because of the capacity reduction. The 5-way stop worked out really well, and of course it's very inexpensive to put in. Okay, but why would the community oppose the roundabout? So construction's a possibility, but they got the construction anyway. It's change. Okay, who goes to community meetings? Old people. Now, why do old people go to community meetings when you guys are the ones who are more vested in your community because you're going to be alive longer? They're retired, they have extra time. So old people govern local community decisions. This is a really important thing to remember if you're going to be a practicing engineer working in for a public agency or for a consultant that works for a public agency. That the people who turn out for community meetings are disproportionately old, and old people are disproportionately reluctant to change. So that's an issue. Okay. There were 2 complaints that the community had. Okay, one is that the roundabout's not going to work. All your science and magic and stuff, we don't believe that. Okay. The other was that it would work, and therefore it would increase capacity, and therefore there'd be more traffic on local streets because you've increased capacity. Okay, so they were simultaneously arguing it wouldn't work and it would work, and therefore we shouldn't do it, which is a really fascinating argument. And I attended these community meetings, and I saw some of this going on, and it was just like a little bizarre. And Hennepin County engineers, the Hennepin County chief engineers, he's not a spring chicken himself, not terribly innovative, and he just, I think, wanted to get the minimum number of phone calls from people complaining. So you can imagine that if it's newfangled, she's sort of the old-fangled word for newfangled, if it's newfangled, that people are going to complain about it, even if it's safer, even if it gets a higher throughput, even if it reduces delay, because people don't like change. So they spent $500,000 or so rebuilding the intersection with new traffic signals rather than $500,000 or so rebuilding the intersection for a roundabout. And it's working well enough that they're not going to do it, and they just spent a lot of money. They're not going to look at this again for a number of years. Roundabout, you'd have to do some things. You'd have to change the grades a little bit and reconfigure it in some ways because of just sort of the geometrics to get the geometrics right. But it wouldn't have, in the end, it really shouldn't have cost any more. Going to leave you with one example from the UK. This is called the Magic Roundabout. And this is what it looks like. Okay. It's actually 5 roundabouts in a roundabout. Okay. This is not a design that you should replicate. It's just something you should think about as sort of a possible, what you could actually do if you're creative. So they had a situation, you've got a set of roads coming into an intersection, 1, 2, 3, 4, 5, 6 approaches. Okay, so it's a 6-way intersection. They have space. This is Swindon, so this is a town, suburb, but more independent town to the west of London. And you've got some special issues. You've got a fire station right near the intersection. You've got some stores along these roads, but it looks like it's undeveloped on the north side. The top of the picture, I'm assuming it's north. And so the traffic flow comes in. Remember, you're driving on the wrong side because this is in the UK. Okay. People are coming into the intersection driving on the left, and they'll merge in. And you've got 4 lanes or 3 lanes or 4 lanes in each direction at this roundabout. So it's complicated. And you've got the center island, but then you've got these mini roundabouts around it. So you're coming in, you're going like that, but you can also turn, and the inside is going in the counterclockwise direction, and the outside is going in the clockwise direction. But there's these mini rotaries where you can change direction. Okay, and it's the trajectories are given. You can see the trajectories of different vehicles in the upper right, and where people would be going. This is a fisheye lens view of the roundabout with a full 360. Okay. And pull back to this one.
4259 olisi Mä en tiedä mistä sinne meni. Voi kauheeta. Oho.
42 mikä?
4259. En mä ymmärrä.
Sitä missään.
No. Minä täytyy varmaan suuntaan johonkin päästä.
Ei me voidaan ottaa sen ympyrän niin kuin löydetään sen.
Niin,
Tämä on mahtava paikka.
Eli
And Drake's Way vai?
Eli poistu liikenneympyrästä tiellä A4259.
Mä en nähnyt semmoista, mutta koitetaan
No
löytää.
onko sit 4312?
Me ollaan tässä keskellä ympyrää. Tuolta me tultiin.
4312 on tonne.
Okei. Tämä selvä.
Voi morjens.
And we just cleared the Swindon Magic Roundabout.